So if you already started, you realize it's very simple. If you know the C or C++, it will take I think 5 to 10 minutes to finish the project A. If you do not, even though you do not know the C or C++, but you know the C++ using the command line application using Visual Studio, so it may take the 30 minutes to 1 hour. If you completely do not know anything about C or C++, even that doesn't take a time longer than the 2 hours. Okay, so but you need to understand how process creation, how to create a process, such a mechanism. Using FOCO and EXEC, so then that is the main part, how to create the process. Okay, if you understand that the process of creating the process, then it may be very easy. Then the B part, you will add a little bit more the functionality on the shell programming. The output of the project 1A part is very simple shell programming. You will have your own shell programming. You can use that shell programming to start any program. Instead of clicking or instead of typing using other bash shell or C shell, you can use your. And how to use? You can start. So when you log on system, when you log on through the SSH or Tela, you can start your program as a first the terminal program. It will be the shell programming. Okay, then any question before we start? Okay, so then we will continue the synchronization. I believe that you study hard during the winter break, not winter break, weekend. So, but I'm going to quickly summarize what we have learned the last time. In case of a race condition means it's multiple processes. So when we have the multiple process plus share. Okay. Such a condition will be discussed not only operating system but any other computing problem. Like the database also, we will see such the problem later. Okay, it's a locking problem, so we will discuss more about this one in the database also. By the way, the textbook of the author of our textbook, he also authored the database textbook. So many of the contents are common between the database and operating system. If you read his database textbook, but I will introduce some contents that will be discussed in the database also. Anyway, the shared resource like the shared memory at the time it caused the synchronization problem. It's a race condition. To solve that problem, we will first define the process as so this is a series of the instruction, but in case of race condition, which means accessing the shared data, we will define the entry section. Entry section means the code provided by the operating system to manage such a race condition. It's an additional code. And then when this part is called a critical section. Critical section is nothing but the event when process access the shared data. Okay. Then exit section. So basically, if we from the locking perspective is getting the lock to access critical section and release the lock when you leave such a critical section. For example, I gave the couple of examples like the using the bathroom. Before you enter the bathroom, you need to get the key. Then when you leave your bathroom, you need to release the key, give the key to other. Okay, at that time we discussed about the 3 requirements of the synchronization problem. So synchronization solution. So one is definitely only the process, one person can use the bathroom. So that is called a mutual exclusion. Okay, only one. Okay, obviously this is the main requirement. Okay, and number 2 is the progress. In other words, This is a deadlock free. Deadlock free means no deadlock happen. Because there might be many the process to use the shared data, same shared data. Accessing this race condition, multiple process are competing for accessing the shared data. So we need to vote. We need to decide one process for the mutual exclusion, right? At that time, such a decision will not be locked. It will not be stopped. It will be continued. The one of the example, simple example, is that you can use the key. Okay, we have the key to access the bathroom. But when you leave, after you complete all the use of the bathroom, if you give the key your friend who are in the library, okay, then who will be the next one? Nobody can use. It's locked. Okay, until the person who got the key return to one of the person who are waiting in front of the bathroom, right? That is called the locking. Okay, so deadlock free, which means the only, if you read the carefully definition of the progress, the only not in the remainder section. This is a remainder section. This is a remainder section. The not in the remainder section will decide the next one among the process who are waiting for the shared data. Among the person who are waiting for the key in front of the bathroom will be selected. Okay? That is the progress. The third requirement is the, is it progress? What is the name of that?
Bounded waiting?
Bounded waiting. Bounded waiting. Bounded waiting, in other words, this is a starvation free. Even though you are select one of the process from this one, entry section, who are waiting for this one. Then, but I like the only computer science student. Okay? So you give always the key to the computer science student who are waiting to use the bathroom, not other. Then those who are waiting for the bathroom, they never got the key. Okay? It's called the starvation. This is okay for the progress. It's not like always select the next one, but some of the process, some of the student will not get the chance to use the bathroom. That's okay for the in terms of progress, but that's a problem. Okay? Never get the chance. So this waiting should not be forever. It's a bounded waiting. But it doesn't specify how long, but eventually it will get the chance. That is the bounded waiting. So if all three requirements are satisfied, that solution is good. Okay, so we need such a solution. So for that solution, we learn the algorithm 1. Algorithm 1, nothing but to use a turn or key. Okay, this is a key. So this is okay for the mutual exclusion, but this is not okay for this. Like giving the key to the person who are in the library. Okay, so in case such a case happen, so it will be the problem on the progress and bounded waiting. So algorithm 2, so instead of using the key, because key is critical, if you lose the key, if something happens on the key, you cannot use the bathroom. Instead, you express the my status. Each student, each process, show the my status. I'd like to use the bathroom. I'd like to enter the critical section. I want to access the data in the shared memory. So using that, the status like a flag. You can, the flag for each, so we can use the array, flag for each process, number of processes. So we have seen that this case based on the two process cases for simplification purpose. But we can extend, so this is also okay for the mutual exclusion, but in case both of them are true, okay, then they cannot access the bathroom and cannot access the shared data at the same time. So that is the basic algorithm 1, algorithm 2. So by combining algorithm 1 and algorithm 2, we learned about the Patterson's solution. So this is the first synchronization solution used in the real computer system, not the operating system. This synchronization is not only for the operating system. It can be used for the many applications. So, however, better solution use both of them. So you can take a look at the algorithm. It's not complicated, but the only problem when students understand the synchronization solution is that entry and exit code for all the process. So don't be confused with the I or J or number 0 or 1. It should be generalized. So it's very hard to see on the one slide. So but the I shows the kind of timeline to check what is the value of each turn or the flag and so on. Please read carefully. It's not complicated problem. So balanced solution actually satisfy all three conditions. A problem is only for two process cases. So this is only for the two process cases. Anyway, this is for your understanding. It's a software solution. It's nothing but algorithm. Operating system just add this one and this part, entry and exit section, the number of some code to manage such a race condition synchronization solution. So this is the then this is a software solution plus there is a hardware solution. In operating system, computer system, hardware means it's a hardware, but we are interested in here. Register is what?
Memory.
It's a register is the storage. Okay, where? CPU, processor. Processor even has the register. What kind of information are stored at the register? Value. Then a lot of the address and so on. Then they can be used by instruction. Okay, command. So that instruction, who defined that instruction? Microsoft or the Android? Intel. Which means CPU manufacturer design as a hardware code. Then follow that instruction to build your operating system. Okay? So, which means the hardware solution means we are going to use the instruction, hardware instruction. But in this class, we are not going to see the hardware design or whatever, how that instruction is organized or the algorithm. So it doesn't look like the different, but for the implementation, this part is a coding. But this part, design hardware. Okay? What kind of instruction? So we have seen the test and send. And another one is a swap. The swap is very easy. So change the two value. So usually key and others. So if you drag the access, then there is a change. We will see the briefly. But the test and set we have seen. Test and set always return. What? Always change the value true and return as input. Okay? Value will be changed as the true, but the return value is the same as the input. Okay? Then using the instruction, we can solve the synchronization problem. Idea is what? Both of them use lock. Okay? Acquire the lock, release the lock. Okay? So this is the hardware. We will see the couple of example of the hardware solution. Plus there is another solution, operating system. What's the difference? Operating system is nothing but the software, but operating system as a data structure. Operating system provides something special data structure to solve that problem. So today we are going to see such a two-speed. We will see. We will use the we are going to use the PDF file. Okay, this is a test and set. So test and set always return the same value as the input. Okay, but the value itself will be changed as a true. So which means for the entry section entry section, we can test and set lock. If lock is false, false means nobody use. Okay, nobody accessed this one. So if you test and set of the lock, what is the return value of lock at the test and set? Same as input, false. Okay, in case of false, we can enter the critical section. We can exit the while loop. Okay, then what is the value of lock? Is change it always to the true. So which means if other process run the access the critical section, which means run the same entry code, then lock is true. So this output of test and set is also true, which means you cannot out of while loop. You cannot enter critical section. You cannot use the bathroom. So, but when the first process who are in the critical section leave the critical section, lock is set as a false. It's exit section. It's a false, which means another process who are running this one infinitely, finally the lock is a false, then test and set is the false, then enter the critical section. So this is the solution using hardware. Benefit is not much different from the other software solution. What is the difference between software solution and this solution? First, test and set is the instruction, which means how many instruction? It's one instruction. Instruction means it's an atomic operation. You cannot divide you cannot stop in the middle of the test and set. However, if you implement this one as a software, it will be sometimes interrupt in the middle of this function. It will be the problem. So this is the atomic. And another benefit, which one will be faster? Definitely instruction is much faster. This one consists of many instructions. This is not actually implemented as the code. It's a hardware design. Okay, it's using the something signal which I do not know. Okay, when the Intel design the hardware, the CPU, define we need 200 instruction. Okay, then in the design chip design they code or the design such a thing. So it's very fast, much faster than the software solution. But it still has the problem. One of the main problem is who are waiting outside. Keep knocking the door, okay? Really fast. If the several processes are waiting for the critical section, keep knocking, in a second, the millionth time knocking, okay? This is called busy waiting, okay? It's a waiting but very busy. It's not just waiting outside. So knocking the door is called a busy waiting. Busy waiting is consume a lot of your resources also. So this is a busy waiting is a problem. And also we will see how to solve that problem after the swap. Swap the instruction is also instruction, but the swap as you understand is swap the value. Like the boolean A, boolean B is a true, false, their value will be changed. Like this is an example. I don't have to explain the mechanism of the swap. But using the swap, how we can use? We have the key. Okay, key is true, which means in case of key is equal to true. So true is equal to true. Okay, then.
Enter the critical.
Then what?
Lock and key.
This one is there's no other command inside the while loop. Okay, only condition. But this one, don't be confused. There's a swap operation. You need to learn the swap operation. So for the swap, the lock is the false. If nobody use, lock is false. Key is true. Then swap. So lock is true, but key is false. Then going back to the while condition, and key is false. False is not true, so it's false. So you can enter critical section. Okay. Then at that time, if another process would like to access this one, log is currently true. Okay? Then that process also key is true, true is true, even though true and true, even though swap is still true, and the other process cannot enter critical section. Then when the first process leaves the critical section, log is false. Then another process who are waiting this, then swap, then finally enter the critical section. This is okay for the mutual exclusion, but both of them, the swap and the test and set, they have the problem of the progress and the bounded waiting. The more important thing is they have the BG waiting. So BG waiting is a really problem in this case. So to address that problem, so we can use the test and set that satisfy with all three conditions. I will give the 1 minute to understand this code. It's not complicated, okay? It's similar as what? Patterson solution. So we have the key, we have the status for each process. Okay, it's waiting here. So don't be confused. So here the entry section, this is the while condition, and this is the statement the inside the while loop, then semicolon, and this is the before enter. Up to this one, both of them are entry section, and this is the exit section. Okay, so is it okay for the mutual exclusion? Probably. And bounded waiting and the progress? Okay, probably. So we will see how it works. So for example, we have the process 1. Let's say the process ID is 1. In this case, I equal to 1. So this process 1 would like to enter the critical section. So at that time, the entry section, first thing is waiting. Waiting 1 is true. Declare, I'm going to wait. Such a declaration will be used for voting later, who are waiting outside, okay? In case waiting. And key is equal to true. I need the key, okay? But inside the while loop, waiting, this is a while loop. Waiting is the what? The true. And key is a true. Which means this is a true. So we can key, test and set the log. So log is currently, if log is a shared data, log is a false. Nobody used. Okay, then what happened? Output of test and set, that is a key equal to same as this one. Okay? But the log is changed always true. The input will be always true. Then going back to the while loop, then check the waiting is still true because I'm waiting, not the enter yet. Then and the key is false, which means this is the false. You can exit the while loop. Then waiting 1 is false because I'm not waiting. I'm inside the bathroom. Okay, this is the entry, so we can enter critical section. So right now, process 1 is in the critical section. At this time, what if there is another process? Process 2. Wait, the 2 is the true. Key, I need a key, this is true. Log is a false or true, currently. This is a true, it's a shared data. Okay, log is true. Then the while loop. While loop is waiting true and the key is true, so test and set. So key is the test and set input is the same as the output of test and set. So what is it's true? So key is true. and the log is always true. The input is always true in the test and set. Okay? Then output of test and set is the same as the input. So it's true. Then going back to while loop, it's still true and true. True and true. Until when? This one leave. However, if this one just leave and the log free, so it will be the same as the previous one. So there is a voting process. So previous two example didn't have any the voting the solution, but here. So later we will see this one. The y. J is not equal to I. J means the next process. When you leave the bathroom, I'm going to select the next process, voting. Okay, so let's use the, I think only 3, 1, 2, 3, 4, 5, 6, 7. 7 students are waiting outside. Okay, so we have the 7 process. Okay, not waiting outside, total 7 process in the operating system. So the 0, 1, 2, 3, 4, 5, 6. The 1 is currently using the bathroom and would like to leave. So we don't have to give the chance to that process. So that is the reason J equal to not I. Okay? So except that process is set. And the waiting, we need to select the process who are waiting. Waiting is true. Okay? So for example, if the next process waiting is false, we can skip next one. So that is this part, J equal to so both of them are true, then we will move to the next. Plus 1, plus 1. Until when? Waiting is true. So first, the processor, also who are waiting to enter critical section, will be selected. Okay? Then at that time, if we select, then give the log is false. But nobody wait. So check the next, going back to here, and it's myself, J equal to I, which means just leave the key. Nobody will be selected because nobody waiting. So that is the exit algorithm. So check the mutual exclusion definitely because we are using the shared log. And what about the progress? Progress means such as is there any log? Can we select any process who are not waiting? So no, because we are checking all the process only for waiting process. So it's the progress is okay. There will not be deadlock. What about the how long wait? Maximum 1 round. So checking all the process. So for example, current process is 1 and check the next, and worst case she will be selected. So just 1 round. So it will be bounded waiting. Okay. So all 3 the condition are satisfied with the algorithm. Key part is here. We are going to check the next, and this one is in case the last process will be next one will be the first process. Okay. Any question regarding to this solution? Best way. So think about the 2 process case, 0 or 1. Then write down the value for each process, and log is the shared variable. Then check which one will be selected and how it works. So all 3 are satisfied. This is a solution. Okay, the next one is the semaphore. I didn't know that until I checked the dictionary. The semaphore means it's a visual communication. The nautical, there's using the flag and they communicate using the hand signal. So that is called a semaphore, like the A, B, C, D or whatever. But anyway, so we are to solve the synchronization problem. So operating system, the researcher, they try to find. So these are actually the basic idea. Using that basic idea, is there any practical solution? And at the time they realized that they need another data structure which is called the semaphore. Okay, semaphore is a very simple. The structure is nothing but the list. It's an integer variable and that represents a list of a process. It's a 0, 1, 2, 3, 4, 5, 6 like that. Each value represents a process. That's it. Then how we can use? So it's kind of the log also. Okay. So in case, so that is the semaphore. So semaphore is nothing but the sequence, the array of integer. That's it. Then each value represents the process. Then there are two operations. One is a P. Sometimes it's called a wait. Another one is a B. It's I think from German. So, but I do not know what it stands for. It's from the German. Mostly we use the wait and signal. So wait. There are two operation methods for this the data structure semaphore. One is the decrease the value, decrement. The wait is decrement. The signal is the increment. So wait is the decrement, and the signal is the increment. How we can use this one? For example, how many processes are waiting? If there is a new student to use the bathroom, then wait. I'm going to wait, which means increase the value. If you use the wait is the decrement. You can give the signal, the increment, and then if you are using it's a decrement, something like that. It's a two operation. It's nothing but just the integer variable. Okay. Then there are two types of such a semaphore. One is a counting. Counting is what I explained. Just counting how many the process are waiting, how many process are signaling, and how many process are in the semaphore. Another one is a binary semaphore, which means the maximum value is 1. So either 0 or 1. Okay? Not sequence, the list of the integer, it's just 0 or 1. So in case of 0 or 1, it looks like the signal I'm using. And wait, decrement. Okay, free. So which means it's the same as log, either true or false, 0 or 1, true or false. It's the same as log. Okay? So sometimes such a binary semaphore is called a mutex log. Anyone who ever used the Windows 95 or the 3.1? 95? From time to time, when you are using the operating system, Windows operating system, you may see the pop-up like the mutex log problem. Do you remember?
No.
So long time ago, when you are using the Windows 95, from time to time there is a pop-up from the operating system, kind of mutex log problem. That actually from the mutex, the binary semaphore, because they at the time the operating system used the semaphore, binary semaphore for the locking to solve the synchronization problem. But it has something, the issue, the drawback, the shortcut of the using mutex log. So if operating system cannot handle such a synchronization problem, then the stop, terminate the process and pop up there is a mutex log, something like that. We will see why that happens. So that is called the mutex log. Okay, so by wrapping up, the semaphore is it's a sequence of integer. In case of binary semaphore, it's either 0 or 1. Then the